This is a gas stoichiometry problem. Suppose that 2 liters of propane gas, C3H8, at 1 atmosphere and 298 Kelvin is mixed with 6.3 liters of oxygen gas at the same pressure and temperature and burned to form carbon dioxide and liquid water. Ignoring the volume of water forward, find the volume of the reaction mixture, including product and excess reactant, at 1 atmosphere and 298 Kelvin if the reaction goes to completion. Okay, so the first thing we need to do is orient ourselves and figure out exactly what this question is asking and how we need to answer it. So we're given a certain amount of propane gas, 2 liters, at a certain pressure and temperature, and the pressure is 1 atmosphere and the temperature is 298 Kelvin, mixed with oxygen. It's going to form carbon dioxide and water. So we need to figure out the final volume of the reaction mixture, which would include the product that we make and the excess reactant, ignoring any water. All right, so in order to do this, the first thing we need to do is have a balanced chemical reaction. So they told me what the reactants were. Propane, C3H8, plus oxygen to give carbon dioxide and water. Okay, and at 1 atmosphere pressure and at 298 Kelvin, which is room temperature, the propane, of course, exists as a gas, the oxygen exists as a gas, the carbon dioxide exists as a gas, and the water is a liquid. All right, so now we have our balanced, oh, no, we don't have our balanced chemical equation. We have a chemical equation, but it's not balanced. So to balance it, I need to have 3 carbons to balance the carbon. I need to have 8 hydrogen to balance the hydrogen, and then I'll save the oxygen for last. And with a little work, I would have come up that it's 5 oxygen. So now this problem reads, 1 mole of propane reacts with 5 moles of oxygen to give 3 moles of carbon dioxide and 4 moles of water. Okay, so we are at constant temperature and pressure because they told us we were at constant temperature and pressure. All right, and we want to figure out what the volume of the gas is, okay, at the end. All right, so let's move down and give ourselves some more room here. Okay, so what's given initially is that we're starting with 2 liters of the propane, and is that correct? Let me see, 2 liters of propane, yes, and 6.3 liters of oxygen. Okay, so we're starting with 2 liters of propane and 6.3 liters of oxygen. And we need to figure out how much carbon dioxide gas. We're not going to worry about the oxygen, we're not going to worry about the water. So what we need to do next is recognize that we have different amounts of the 2 reactants, and in order to figure out how much product is made, we have to decide what is the limiting reagent here. And before we do that, I want you all to recognize something, and that is because the pressure and temperature is constant, we have this relationship when gases behave ideally, which in this case we're going to assume that they are, that when the equation of this state, the final state, is going to be the pressure times the volume equals the number of moles times the gas constant times the temperature. And in this case, the temperature is constant, R, of course, is a gas constant, and P is constant. So if I rearrange this equation, V over N equals RT over P, all of these properties and constants create one big constant. So what this tells me is that in this case, volume is directly proportional to number of moles. And when that's the case, in a gas phase reaction, we can interpret the equation either as moles of product and reactant or equally as volume of product and reactant, since the pressure and the temperature is going to stay the same. And in that case, the number density would be the same. So we can say we have 1 liter of propane gas reacts with 5 liters of oxygen gas to give 3 liters of carbon dioxide and some water. We can't do the volume mole ratio for the water because it's in the form of a liquid. But that's okay because we don't care about how much water we made in this particular problem. Okay, so now keeping that in mind, we can, instead of talking about moles here, we can just, we don't have to convert from moles to liters. We can just go straight away and talk about liters. All right, so we have given 2 liters and 6.3 liters. And from our balanced chemical equation, we need to figure out which is the limiting reagent. And so in this case, the propane is 1 liter of propane reacts with 5 liters of carbon dioxide. So we can say that they exist in a 1:5 volume ratio and when they react completely. But we're given 2 liters, and if we had the correct ratio, in order to react all 2 liters, we would need to have 10 liters of carbon dioxide. That's not the case. Oh, excuse me, not carbon dioxide. No, my bad. Oxygen, obviously. Okay, so 1 liter of propane reacts with 5 liters of oxygen in this balanced chemical reaction. So it's a 1:5 volume ratio. We are given 2 liters of propane gas, so we would need 10 liters to react all of it away, but we only have 6.3 liters. Okay, we only have 6.3 liters. That tells me that oxygen is my limiting reagent. Okay, so knowing that oxygen is my limiting reagent, I can calculate how much carbon dioxide will be formed across this chemical change. Okay, so we've just discovered that oxygen is the limiting reagent based on the volume-volume ratio. All right, so that's the limiting reagent. So now we can work the problem. And we can say, given 2 liters, excuse me, 6.3 liters of oxygen, how many, let me see, wanted, how many liters of carbon dioxide will be formed, assuming excess propane, because we have excess propane. And so the conversion path in this case is going to be from liters of oxygen to liters of carbon dioxide. And because of our volume is proportional to mole situation here, because it's constant temperature and pressure, then I can, from the chemical reaction, I can see here that it's 5 liters of oxygen are used for every 3 liters of carbon dioxide formed. So it's a 5:3 volume ratio or molar ratio, but they're interchangeable here. So the conversion factor from oxygen to carbon dioxide is just going to be the reaction stoichiometry. All right, and so to work it, we start with what's given, 6.3 liters of oxygen. Convert using the reaction stoichiometry. There's 5 liters of oxygen for every 3 liters of carbon dioxide formed, and that equals 3.78 liters of carbon dioxide. So that's how much carbon dioxide is formed in this case. But in addition to that, the question asked the total volume including the excess reagent in the container. So this is the product, the volume of the product. They said don't worry about the water, so we don't have to worry about the water. Now we just have to figure out how much of the propane was used up so we can figure out how much of the propane is left over to add to that volume. And to do that, if you look back at the balanced chemical equation again, it's 1 liter of propane reacts with every 5 liters of oxygen. So I can figure out how much of that is used by saying, okay, if I know I'm going to use 6.3 liters of oxygen, I want to know how much volume of propane is used up. I can again use the convert directly from liters of oxygen to liters of propane, very similar to what I just did up here, and I'll use the reaction stoichiometry as my conversion factor, only in this case it's going to be a 1:5 ratio. So start with 6.3 liters of oxygen. From the balanced chemical equation, for every 1 mole or 1 liter in this case of propane reacted, I react away 5 liters of oxygen. So that's going to cancel, leaving me in units of liters of propane. and that is going to be 1.26 liters of propane consumed. All right, whoops, C3H8. All right, so the total volume, oh, that's how much is consumed, but I started with initially 2 liters of propane. So if I subtract the consumed from what I started with, I'll get what's the leftover, or the remaining leftover is going to be 0.74 liters of propane. So the total amount of gas left in the reaction vessel at the end is the product that was formed. There's no oxygen, it was all used up, and the leftover reactant. So the sum of 3.78 and 0.74, I'm going to put it up here. Well, I'm out of space. We'll have to go. Okay, it's going to be the 3.78 liters of carbon dioxide plus the 0.74 liters of propane is going to add up to a total of 4.52 liters of gas in the vessel at the end. Good job.